Okay, guys, welcome to our first Q&A sessions about Chialisp. Today, we're going to have two panelists, Matt Howard, who is probably the best Chialisp programmer in our company, and Richard Kiss, who wrote the original CLVM and loves the rerun and run versions of running Chia smart contracts. And then I am Richard, also known as Efficient, who will be your moderator. If you actually have questions, please use the Q&A button to ask questions. We're kind of going to take it only from there. Feel free to use the chat to just have fun, but anything else, please use the Q&A button. If after this session you're interested to do any follow-up questions regarding to Chialisp, you can find us on Keybase and the Chialisp sub-channel. So with that, I am going to start. I'm going to stop the screen sharing so you can see our lovely faces. And I guess it's up to the participants to start typing questions, which you have none yet. So Matt can probably give a trivia about Chialisp or something in the meantime.
Well, Richard, do you want to talk about Chialisp Rust, which is the next big iteration on Chialisp, probably?
Yes. So CLVM was originally implemented and researched in Python, and we found that running it in Python was too slow, so we re-implemented it in Rust, which that's the CLVM _RS Python wheel that's included in Chia blockchain. And the past couple of weeks, I've been working towards retargeting CLVM RS for WebASM, so it can work with JavaScript and work in web browsers. And we have a proof of concept that runs it, and it runs very fast, much faster than it would if it were implemented in just JavaScript. So that's pretty exciting. That's not merged into main yet, but we should have the proof of concept merged into main, and then we can work on providing more visibility into the Rust API. But I expect that will help people who want to implement wallets or other software that runs in a web browser.
Cool. Since it seems like we're quite so far. Oh, here we go. Can you give some examples of applications that the Chia team feel are missing in the ecosystem? What would be a good my first Chialisp project for a curious engineer to tackle?
Well, the first thing that I'd recommend a curious engineer do is the password protected coin. I love this example because it emphasizes the coin-centric approach and gives you familiarity with a bunch of the different systems, writing Chialisp, the conditions language. But in terms of stuff that's missing that I'd like to see two-player games. I would love to see checkers, something like that. We've got the singleton layer now, so I think it's only a matter of time until someone creates the Chia equivalent of CryptoKitties.
Chia pets.
Don't know if we're allowed to say that.
Oh, Chia NFT pets. There you go.
There we go. But to be honest, any projects from the community are appreciated. The Chialisp Keybase channel is watched quite closely, and I always enjoy seeing what people are up to.
Typically, when you start with a new programming environment, you write a toy first. So I would say write a toy first, because writing a toy gives you a good idea of what is possible. And when you're writing and debugging the toy, a lot of times ideas about what you can do come to mind.
Okay, somebody's asking about, can you describe offers in details?
Yes, I can. So offers are incomplete spend bundles that have been turned into a file. So a spend bundle is what you send to the network to spend money. But what you do for an offer file is you create a spend that says, I'm willing to give away this money, but I'm expecting some money in return. And so that spend on its own is not valid because you're not getting the thing in return, and the two things are locked together. And then you circulate this around, and people can read that file and go, oh, he's giving away this in return for that. And to accept that offer, you can see if you have what they're looking for and make the corresponding shape, which I suppose would be this. And then if you if you put those together, that becomes a valid spend bundle. And so the person who receives it gives the person who created the offer what they want, and that is a trade.
And to be clear, this is in the context of colored coins. So presumably colored coins would already be issued and would correspond to real world assets. Like you might have a colored coin which corresponds to US dollar coin. And then so these offers would let you trade Chia for dollars in a decentralized way.
So as a follow-up question, while I haven't seen other questions come up, is there going to be sort of like standards that people will have to follow, like the ERC20 token, standards? How do people know that they're doing things right, I guess?
So really what we've done with the singleton layer and the colored coin layer is they are, in a way, that standard, in that this is a protocol layer. Protocol might not be the right word there, but this is a layer that you can choose to use in your applications. And if you do, you're guaranteed interoperability with these things. And that's the same guarantee that following the ERC spec does. It says, if you implement these, then you can use these services. So we've sort of got it as it is.
Okay.
Yeah, it's coming very soon.
Okay, cool. Who finalized the offer? How does it happen that two partial offers become one valid transaction?
So as I said, it's the offer itself is already a spend bundle that could be sent to the network. It's just a spend bundle that would get rejected because it's expecting money to appear. But as soon as you make that valid by saying, I'll give you that money, and then you put those together in a box, that is a legal spend that you can just send to the network, and it will spend the offerer's money and the offer acceptor's money, if you understand.
So I'm just extrapolating here. Does that mean that, for instance, somebody who's going to create this has to create sort of like a website where it would kind of show these offers and then this code, or is it?
So you could create a website, but it's really independent of that. It's just like a file. It's just some data. So you can send that through. You can send an offer file through WhatsApp or post it on Reddit, or anything else you like. As long as someone can read, you could make a website where people can look at offers, but the offer files themselves are sort of independent of that.
Okay.
In a trade, there's a maker and a taker. So the maker makes the offer, and then the taker looks at all the offers that are made and chooses one or more and takes them. So the maker would post on a public site like, I don't know, Reddit or something, and then the taker would look at the offers that are still open and choose one.
Okay. So as a follow-up for that, how do people know offers are still available? Do they have to look at the blockchain? Do they have, like, how do they know it's like the offers are still valid, right? You can post it for years, right? I mean, technically. Yeah,
unfortunately, if the coin is spent, then the offer is invalid. But there's not much harm. You can look it up. You can check the blockchain, Block Explorer.
Right. Yeah, the offer has a coin or multiple coins that are listed in there, and so you have to make sure that those coins still exist, because once coins are spent, then poof, they're gone.
Okay, great. So can an offer be curried into another spend?
I mean, as bytes, I think you're using, I don't know what you mean by curried there.
Carried? Yeah, curried has a specific meaning to us, which is overloading my brain right now.
I think what he means
like,
is
making it hard for me to interpret this question.
Okay.
I think what he means is like, could you take that and do it as part of a bigger spend bundle? Like, as long as you satisfy the conditions in the offer, you can include that with whatever spend bundle you want. Yeah. I think that's what you're asking me.
If that was not what you were asking, feel free to do a follow-up question. Okay. We'll switch to another question that's interesting. Could I write my own personal layer 2 app that provides clawback and rate limited spend? Because we don't technically have those as references yet.
Yeah, yes, you can do that. If you want, we've
correct,
got a hackathon going on, you could do that and submit it.
The correct answer is go for it.
Okay, cool. So what happens, let's say, hypothetically, somebody writes this and then you guys come out with an official clawback and they're realizing, ooh, the one they wrote isn't as good as the one Chia wrote and we want to use the Chia one. How can they some kind of migrate towards it? How does that work?
I mean,
I would say just make yours better than ours. And then you won't have that problem.
in terms of like migration from code, really you have coins that have some restriction imposed on them and coins that don't. So once you have your coin free from the clawback or the rate limiting restrictions, then you can put the new version on it if you want. But if there are restrictions on that money, you need to obey the rules. But once those restrictions have worn out, then you're free to do whatever you want.
Right, exactly. Yeah, I mean, you can't, just because there's another version written doesn't mean that your old version's rules don't apply anymore.
So is it a smart strategy for us if you're creating the version of clawback that we want in the future, we want to upgrade it, that means we have to somehow invalidate that other one by satisfying the rules of the old clawback and then transfer the funds to the new clawback? Just trying to work through how that really would work. Because clawback is a really interesting one, right? Like if there was a bug in the clawback of however, we wrote it, but then you guys wrote a better one,
I mean, clawback, to my understanding, is where you send a transaction and there's a time period where you can sort of undo that transaction. But after that time period is over, that becomes unrestricted money again. Okay, good point.
Well, actually, I mean, to be clear, I think it's impossible to do it exactly that way. I think what happens is the money is in this escrow account where both people can reach it, and the final recipient can take it out after a certain time period, so that the initial sender, but the final recipient has the choice to just leave it there indefinitely, which means the original sender could take it out at any time.
Okay. So there was just a commentary here from somebody in chat. Chialisp was a low-level language, but they're hoping there's a high-level language soon. Is Chia Network planning to do a high-level language?
So to clarify, we have a low-level language and a high-level language. The low-level language is called CLVM, and Chialisp is built on top of that. But there's nothing to stop people building more higher-level stuff that compiles down to CLVM. CLVM is what runs on the blockchain. So any tooling you write that ultimately compiles down to CLVM will be fine. I think we have plans to expand our high-level language, Chialisp. I think that's what Artie's working on, right?
Yeah, he's working. He has a compiler that is better than the existing compiler, I believe. And I'm not too sure what the plans are for productizing that, but I do know that that it'll happen at some point.
So more rich high-level features are coming to the high-level language.
Or I
Yeah.
should add, from a Chia perspective, we're hoping that the ecosystem people will actually create, their own
Sure.
as well on top of that. So
There's a bit of a mismatch between general von Neumann type programming, so I think it would be hard to write a Python that compiles well down to CLVM, but I haven't thought about it too much, so maybe it would be possible.
I think the one that everybody's asking for all the time is there going to be a Solidity to CLVM compiler? Any thoughts on that, Matt?
I don't think so anytime soon, just because of how different those languages are. You have like an object-oriented language in Solidity and the functional language of Chialisp. I think you'd have to be a lunatic to try and map those to each other.
Also, I mean, I'm not an Ethereum expert, but I suspect that Solidity has some functions for interacting with the blockchain that Chialisp does not, and Chialisp has mechanisms for interacting with the blockchain that Solidity does not. So there's probably kind of a mismatch there.
Okay. Is there going to be a Visual Studio Code extension for Chialisp?
I think there is. I think I've seen it. I think someone working on that. We have an Atom extension, and I think someone's working on a Visual Studio one.
Okay. So, as people are, participating in this hackathon, that's one way of joining the Chia community. What are other ways of getting involved in the Chialisp community?
I mean, you can make things that aren't in the hackathon. We already had a community before the hackathon. You can join the Keybase channel and make fun things. We'll respond to your questions. But yes, but everyone's encouraged to make Chialisp applications, even if they're not a part of the hackathon. Aside from making Chialisp applications, respond to GitHub issues.
I didn't directly work on Chialisp related stuff, but for my story, I joined the community by doing pull requests, and I'm sure there's going to be a lot of pull requests of, sample code or example codes, in the Chialisp as well. I haven't actually looked myself, but I'm sure there's lots of opportunities, if you just join Keybase and just, start poking around there, I think that's a good start, for people. So, okay. Anybody wants to talk about what's coming up being refactored in DID, colored coins? Matt, you want to talk about a little bit what's coming up down the pipe?
Yeah. If people are familiar with Chia, we had demonstrated DIDs and colored coins in the past, but for the last 6 months, I don't know how long, they've been disabled because we sort of realized we could do them better, and we wanted to let the world have the best version of them. So coming up, we have the revised versions of both colored coins and DIDs, and those will be very exciting when they're ready.
Yeah, there are always these two competing tensions in developing software between getting it perfect and getting it out. And those tensions are really amplified when it comes to blockchain and contracts, because once a contract is released, it's locked forever. You can't really patch it. You can't do a re-release. You could do a new version, but then you have to migrate all the old version stuff over to the new version. And that old version stuff is going to be around forever. So that adds an extra level of excitement to this kind of software development.
I should add, in this particular case, we do run a test net, and there is a way to get onto the test net, join the Keybase community to talk about that. And I think we have some instructions somewhere on how to set up testnet. If you don't know how to, just ping in the Keybase and ask on the testnet, how do you set up? And that's our number one suggestion. Once you do your own local testing, put it on testnet and have other people try it, because that's a very harmless way to verify a lot of things before you put it on for real. So, okay. Oh, this is a cool question. So how would you approach adapting the piggybank tutorial, which is awesome, but Quexington, by the way, such that the funds can only be cashed out on a rainy day using external weather service data to verify it's raining? So basically, can you somehow get external Oracle data or some kind of data to help drive those decisions in the smart contract?
So oracles, as they exist on Chia, would be done through coins which create announcements. So I was thinking about this just today, actually. I was talking with Adam Kelly, one of our other Chialisp programmers. So let's suppose we know that this specific coin, it could be a singleton, could be a coin, is run by the weather station. Let's say this is BBC News weather coin. And you could simply build in a spend case, because remember, you program coins in terms of what rules govern this. So you can say all of the normal piggy bank rules apply, but also I could spend this if I have an announcement from the weather coin saying it is in fact rainy. And I think if you look at Adam's video that is going to be coming out, there's some demonstration code in there that is a number oracle that there is a magic number man who controls the number oracle, and you can only spend your coin if you have the right number from the number oracle. So that can be expanded to be weather. Okay.
So question that I'm interested to find out is, NFT, is quite the buzzword these days. How does Chialisp kind of achieve sort of like the NFTs that a lot of people are using today for trading art and, the crypto kitties, as you mentioned, and other things that use NFTs? Is that the singleton? Is that something else?
So the singleton layer it enforces one part of the rules that make up NFTs as it's used in common parlance. NFTs for art have the singleton-ness and then some other stuff. So the singletons will be a part of art NFTs as they appear on Chia. And it will be singletons plus maybe a layer that stores information about that art, and then a layer that controls ownership. But the relationship between what an NFT is and what a singleton is, NFTs will be a kind of singleton.
Okay. So does that mean that we need to wait until Chia releases the DID and color coins to achieve this, or could we technically just write our own from scratch?
I mean, the singleton layer is already out. We already used that in the pool protocol, and it's not a secret. So you don't need to rewrite singleton layer. You can wait for Chia to do art NFTs. Don't know how long you'd be waiting. But if people were motivated to make their own art NFTs, I'd suggest they start with the singleton layer and then write an art layer with the expectation of an ownership layer underneath that.
Okay, cool. So did you get to finish talking about what's coming up with color coins? I think we sidetracked.
They're coming out, we're working on it.
No dates.
There's some existing documentation and videos of me talking about how they work, and they'll still by and large work the same way, but really we want to make them more powerful, stronger issuance rules, stronger compatibility with other smart contracts. We're really just upgrading it, like what it can do. So all that stuff is to be looked forward to.
Okay, cool. do you want to talk a little bit about the rate limiting wallet, what you perceive needs to be done to get it up to par from what you guys had already from the mainnet launch?
So that's another one that we when we were developing pre-release, we wrote a bunch of example smart contracts, and rate limited was one of them. And we sort of realized after we were writing DIDs that it would be really cool and powerful if a DID controlled the rate limiting, and if that was tied to singletons and DIDs. And so I think a lot of what this, I guess you could call it the second wave of contracts are going to be, is designing with interoperability with each other. And that's what's going to happen to rate limiting, is it's going to be compatible with singletons and DIDs in a way that'll be cool and powerful.
Cool, awesome. Since we don't have any more questions right now, I'm going to give the opportunity for Richard to tell a story about what in the past was a really challenging problem when he was creating CLVM, just to give some insights on, you know, the journey getting here, because this has been a long journey. For those who don't know, this is a 3+ year journey, you know, so I'm sure Richard has some great stories. You got one to share off the top of your head? I'm sorry, I'm putting you on the spot here.
I mean, I've been working on it for years and just been going in so many circles. It took me a while to realize the minimal set of operators that's required for CLVM to become an actual language that supports, that is Turing complete, and it supports looping of some kind. And the only looping it supports is recursion. And it took a while for me to further realize that you have to use a trick like what's called the Y Combinator, not to be confused with the VC fund, which takes a function that's almost recursive and turns it into a function that actually is recursive. And it's sort of a clever trick where the function gets, the almost recursive function gets passed a copy of itself. So it can call itself. And then when it calls itself, it also has to pass the new self a copy of itself so that this recursion can continue. And that insight is part of the trick, which I sort of accidentally reinvented on my own, even though it was quite well known at the time.
When I first joined Chia, it was coming off kind of an experimental leg where Bram and Richard had been trying, well, what if the coins don't have amount as an intrinsic value? And it was sort of like this come down of, actually, that's a bit silly. We should definitely have amounts be an intrinsic value to the coins. But there was a lot of.
It would be possible to implement it that way, where the coin has no intrinsic value, but rather it's just curried into the puzzle. And then at sort of a higher layer, you do the accounting where you make sure that the inputs and the outputs are.
Oh yeah, when we were designing colored coins, we were thinking colored coins might not necessarily need to correspond to their actual value.
Right. Yeah, they could all be zero coins.
Cool.
Right. This year actually was when so the quote operator is different from the other operators in that I like to say the shape of it is different. If you want quote to return 100, then you have to go open paren q dot 100. So it's just a cons box with a q on the left and 100 on the right. Whereas everything else, all the operands are passed in as list form. So if you want to add 100 to 200, you go plus 100, 200 as a list. So there's no raw cons boxes in there. And changing that, quote used to be similar to all the other operators, but we thought, oh, we can save a little bit of space by changing it to a cons box operator, because we know quote's always going to take just exactly one parameter. And that change was unbelievably complicated. You would think it would just be 1 or 2 lines, but the compiler had to change, and changing the compiler is so much more work than you could imagine. So it's amazing how just tiny little changes like this propagate. And we also renumbered all the opcodes just to make sure that the code could deal with it, and that was quite a pain too. There is one embarrassing thing that happened where the standard puzzle is called pay to delegated puzzle or hidden puzzle. And it's basically the Chia equivalent of taproot and graft root. And the hidden puzzle is the taprooted puzzle. And originally the taprooted puzzle by default was a puzzle that always failed by returning an exception. It was just a paren X. And when we renumbered the opcodes, we, and when I say we, I mean me, forgot to change that puzzle. So it's now actually open paren equals close paren, which luckily still fails. But that's an anachronism that will live on for infinity.
I forgot about
Much
that.
to my shame. I will never forget.
It's okay. Awesome. There's been a couple questions about the hackathon, and I want to just be very clear. We have nothing to do with the hackathon in terms of how it's organized and what's being done. What we try to do is commit ourselves to at least prepare enough Chialisp training materials so hackathons can actually happen, reasonably well, right? I mean, there's a lot of information and knowledge that unfortunately only Chia network folks kind of had experience working with this because they had a head start working with this stuff. And what we're trying to do was make sure that we gave you that knowledge before you start your own hackathon, so you had a better leg up on that. So anything to do with the hackathon itself, you should kind of address to asking Serious Labs on their particular social media channels, Reddit, or even asking Keybase, because I know one of the organizers actually answers questions there. But we don't have any answers to anything related to the hackathon. I apologize for that. We're just focused on the training itself. So interesting question here. I actually like to hear this from Matt is, what things do you think you can do on Chialisp that is either very hard or impossible to do in Solidity?
So it's, as I've talked about elsewhere, they're both Turing complete languages, and you can, in theory, do anything with either of them. But what you have is strengths in different areas, where the coin-based approach really strengthens Chia for financial applications, where you're thinking in terms of what rules and the money. But in terms of actual features, the Chialisp support for HD keys and key derivation, I don't think Solidity can do, because Ethereum doesn't support HD keys to my knowledge. Richard, do you have anything else to add?
As I say, I'm not an expert on Ethereum, but yeah, I mean, you really nailed it that in theory, Turing completeness means that the languages are equivalent. However, there is this extra wrinkle, and that's both are limited by cost. So it may be possible that some things are possible in one language and not in the other, just because the costs don't exactly line up. So maybe there's no way to write a particular program in one that is lower than the cost of a block. That is possible. Also, I guess Ethereum, you really do have unlimited cost, because you can give any contract as much gas as you want, right? Or is there a limit? Is there a gas limit for a block? Do you happen to know?
Not off the top of my head right now.
Yeah, I've never really understood gas in Ethereum. I think really the main differentiators are the underlying blockchain and the coin versus account model. I believe in theory, you could probably embed any EVM program as a CLVM program and vice versa. And there might even be a way to automate that translation, but the automation would be much worse than just rewriting it.
I think one of the videos that is going to come out talks about how with singletons you can achieve very similar things to Ethereum contracts, where you have this consistent address that you can come back to time and time again. And I feel like we've maybe answered this question now. I don't know if that we've been asked what is an HD key. So that is
hierarchical deterministic.
Thank you. And that means that you can derive child keys from it. So if you look up our BLS library, you can see more about that. We use that for signatures and aggregated signatures.
Yeah, it's basically so you can have just one secret that you keep, and that's sort of the root key. But then you can generate as many addresses and subsecrets as you want from that one, so that you don't have to store. You could have a billion keys, and you don't need a DVD-ROM to store them, because you just need the one root secret.
Cool. So to elaborate a little bit more about videos we're going to publish in the near future. So Adam already mentioned, Matt already mentioned one more video coming from Adam. And that's kind of the extent of videos we have planned right now. We're going to kind of assess where our big holes that we have, and maybe we'll do some follow-ups. But right now, there's only one more that's planned right now. So, and with regards to what I was to say, follow-up, like training and things like that, we're hoping by doing this and answering questions on Keybase, the ecosystem will kind of start bootstrapping and starting sharing codes and examples. And you are in the start of a new revolution, so it's going to be a little rough, but we're hopeful that you guys being first, you'll have an advantage of getting a head start and hopefully putting your dApps on before anybody else thought of that idea on hopefully a really what I'll call innovative way of doing blockchain now. So some few follow-up questions here. Do you expect Chia's proof of work in space to kill all proof of work cryptocurrencies with a 10-year span? This is not exactly Chialisp related, but I'll let it pass because
Can we have 11 years? No, but seriously, making predictions is kind of dangerous, especially with regard to the future.
Yeah.
So I'll just say yes, why not?
I'm gonna just say, I honestly think there's going to be multiple winners. I cannot say who it's going to be, but I think in the proof of space and time arena, I think Chia will be the winner, obviously. But I think there is place for different types of blockchains for different problems to be solved. Right? It's simple as that. So I don't think there's going to be just one winner. Yeah.
In 10 years, will there be more coins than there are now, or fewer coins?
Blockchain is forever, Richard.
Yes,
it's not like
that's true.
That's true. Exactly.
Well, you could say blockchains that have created a new block within the past year.
Cool. Some more technical questions here. What is Coinbase property attached to the coin? In the docs, it only says it's a Boolean. I'm not sure.
There are only three things in a coin: its parent ID, its puzzle hash, and its amount.
I think this is referring to rewards.
If it is a Coinbase reward, then it has a special parent ID that is derived from the block height and the some information about the start of the blockchain to say which network it is.
Genesis, yeah, the Genesis challenge.
Yeah. So that
I'm not sure why we have that Boolean. There's a Boolean in the database which indicates whether or not it's a reward coin, and I'm not sure if we actually use that for anything, because a lot of blockchains, they require reward coins to sit there for 100 blocks or whatever before they can be spent, but I don't think we do. So I think maybe it's just trivia, database trivia, but I might be wrong about that.
Okay. Another question is, are there any plans for a schema or heuristics of the Chia system being produced so new developers have a better way of understanding the logic flow?
We hope this stuff will become more obvious. There's a lot of moving parts with Chia, and a lot of it is already mapped out. But I think the community is going to build up sort of intuition and understanding and resources. So the stuff that's not clear, more documentation will come out that helps to clear that up. Yeah.
Yeah, the tendency is for, for open source projects, as time goes on, they become better and better documented, and blockchains in particular, because they can change so slowly. Typically the core structures only change through soft forks. That means it's easy for the documentation to quickly get much better, because a lot of things, there's no risk of them changing.
Yeah, I think one of the things I'll add to this is the very, very early days of Chialisp programming. Okay, and even for ourselves, when I say ourselves as being Chia Network, we learn a lot by just doing. Right, we did the pool NFTs, and we learned so much from that. That's why we're saying we want to revisit, DID. We want to revisit color coins because we learned so much from doing it. So one of the things that I suspect in the next 6 to 12 months is, as a lot of these early dApps start doing things, they're going to learn a lot, and as an ecosystem, we're going to start realizing these are the best types of ways of doing things. These are the type of heuristics and schemas we will do. But it is a combined learning effort, because there's no other blockchain that does it quite the way Chia does it right now, with coin-set model and with the very limited Chialisp, operators. So it's a learning process for everybody, including ourselves, right? We're not going to lie, but we feel this is the better way, because at the end of the day, we want it more audible. We really want to make this very secure, and audibility is important. And that's why we created this particular model. Okay, so it does take a little bit of mindset shift to get there, but once you get there, we feel it's the better way. And actually, I think, Matt, this would be a good segue for you to kind of tell your story of how it took you a while to kind of get that mindset shift from Ethereum to,
so when I first joined Chia, it was with the understanding that I was going to be working with this newly developed Chialisp that Richard was starting to firm up, and I have a lot of sympathy and empathy for the people who are coming at it now, because I distinctly remember sitting down and going, what the hell is this? What is this? And working out the first few programs. I remember that the aha moment for me coming in was once I started understanding where the code was stored and where it was running and when it was running. So even now, I feel like this is hard to get across. I spend my life trying to find new ways to phrase this, but you commit to some code that will run in the future, and then when you spend that coin, you say, okay, here's what that code actually looks like, and here is also some extra data, and then that gets evaluated once when it's being included, and again anytime people look back at the blockchain. So once you get your head around where and when and why that code is running, like the contexts, it should help. And also just functional languages is not something a lot of people are familiar with. So there's going to be some getting used to not having for loops or something.
Yep. Okay, cool. So we have about 13 minutes left, and I do want to give everybody a chance to ask any questions. I just want to give everybody a heads up. We have 13 minutes left, so if you actually have questions or waiting for the last minute, probably is now time to ask some questions. In the meantime, any stories that you want to share, Matt, on what key learnings you had when you developed the pool NFT that really you like to share? Because I think a lot of people are going to read through the pool NFT code and try to kind of figure out why did you do X, Y, or Z as a learning thing. So it'd be cool to, highlight some interesting things that you learned as you were doing pool NFT and why you baked it into the code that way.
Yeah, that was an interesting experience because the Chialisp code was sort of the first thing to firm up, or it needed to be the first thing, and that everything else would get built on top of. And what would happen is we'd come up with a version, and then we'd get a room together and scrutinize this code very heavily in two ways. How can we make this like optimize and operate better, but also like trying to pull back and think, are there big picture ways that we could be doing this better? And anytime we iterated, we were sort of asking ourselves those two questions. I think the biggest, or one of the bigger realizations we had, was this concept of what we called truths, which is we realized with our layering system, where you have inner puzzles and then layers above that, we realized that having these be totally independent is actually inefficient, because a lot of the time layers lower down ended up recalculating information that had already been calculated in the layer above. So if inner puzzles were able to receive information that the outer layer thought was useful, it would save time recalculating it. And once we were thinking about that, that was probably, I'd say probably the biggest change revelation we had. And that is also something I'm going to take back to colored coins, because that design pattern will also happen with inner puzzles in colored coins too. So yeah, I think that answers your question.
Yeah, that's a great story. So, Richard, when you first talked to Bram about this whole idea of creating this whole new CLVM, how did he present it? And how long did it take you to figure it out? I'm sure there's some interesting story there, because at least for me, whenever Bram says something, it takes me like, I need to hear it like 10 more times in different ways before I get it. So I'm curious about, for you, did you get it right away, or did you have to ask questions? What's the background to that?
Well, I started a long time ago, and when I first started, the original plan was to start with the Bitcoin code base and tweak that, because the main innovation that we had at the time was proof of space and proof of time, which even that wasn't fleshed out, but we knew how that was going to work. And I wrote this open source project called PyCoin, which implements Bitcoin's scripting language, the Bitcoin equivalent of CLVM. And there are not a lot of implementations of that in the world, but I'd written one that was consistent enough with the C++ code that it passed over 1,000 tests. I was fortunate enough that someone contributed all these tests to PyCoin and some fixes for some of the tests that were broken. So it was extremely compliant. So I'm very familiar with how Bitcoin's VM worked and a lot of the warts of that. Bram knew the basics of it, but he didn't know all the details. I mean, there are very few people who knew as many details as I did. So I wasn't too thrilled on the idea of using Bitcoin's code, because I find it to be a bit of a mess. There's a lot of spaghetti in there, circular dependencies that are hard to extract. So I really relished the idea of presenting the flaws in the Bitcoin VM so that the CLVM project could exist. And I distinctly remember presenting some of these things to him, and just the horror, the look of horror on his face that emerged. But I also have a lot of evidence now that Bram is not actually Satoshi, because there's so many of these things that just shocked him so much that it would have been impossible for him to have been the author.
Wow, we got some really interesting debunking of Satoshi there. Okay, awesome. This is not exactly Chialisp related, but because we don't have that many more questions, well, I'll entertain it. I'm not sure if either Matt or Richard can answer this, but I'll throw it out to them anyway. What is the role of Time Lords in Chia?
Richard?
If you think of, so proof of space really is a number being drawn, like a lotto ticket number, and everyone checks their plots to see if they have a winning ticket that corresponds to the numbers that are drawn. The numbers are 32 hex digits, it's 256 bits. So nobody will have an exact value, but everyone checks to see how close they are. And if they're close enough, then they might have a winning plot, and they submit it to they gossip it around. I think the first six, the best 16 tickets are paid out. And these values act as entropy and are sent to the Time Lord. And what the Time Lord does is it does the proof of time, where it takes these values as a seed to generate some other value in this group called, what's it called? It's the thing that Gauss invented.
Minkowski proof? I'm not sure if that's it.
The name is, I'm having a brain fart and the name's escaping me, but basically it takes this number and it squares it a whole bunch of times. And it generates a proof of time, a proof that it squared it the correct number of times. And it's akin to spinning a giant Price is Right wheel. And it spins it for, like a minute before the next value comes up. And then it proves that's the value that came up that was spun. So basically the short answer is a Time Lord ensures that the person generating the proof of space can't cheat and spin the wheel in such a way that the next number that comes up is beneficial to them. I did a terrible job of explaining this, but the Time Lord.
We're not the experts in this. No. This is Chialisp. That's why I said we'll give it a shot. But to be clear, there's a whole other team that focuses on the blockchain tech itself. Okay, to be very clear, blockchain tech could kind of work independently, CLVM, except for the coin set part. So you'll notice even in our teams, we're kind of split by. They're experts on the Chialisp side, the CLVM side, the smart contract side, for the easier way to say it. And then the other side who focuses on the blockchain tech. And this would be one that we probably would just generally have in the AMA for the blockchain tech side questions normally to answer. So, okay.
Yeah, the layers really are split very cleanly in Chialisp. I like to say there's this line where the blockchain grows on, and the proof of space is above the line, and the Chialisp stuff is below the line.
Okay, cool. We only have a few more minutes left, so if you're holding out, this is the time. If not, in the meantime, I'm going to, again, put our panelists on the quick hot seat here and give a bit of a trivia of yourself that you don't think anybody knows about yourself. We'll start with Matt. Get a little flavor of who you are, Matt.
I like to play music. I play the synthesizer, and so I program sound waves as well as Chialisp contracts.
That's kind of cool. Anything that you want to share on the chat just for funsies? You have a SoundCloud account? You must have a SoundCloud account then.
I don't think people want to hear that, man.
Okay, if you want to hear him, you could DM him a Keybase message, direct message on Keybase or his SoundCloud account, okay, to check it out.
Do we need to add trigonometric functions to Chialisp so you can do your synthesization in Chialisp?
Okay. Oh, look at this. Somebody knows you well. Favorite Spice Girl. What's your favorite Spice Girl?
Oh, my favorite Spice Girl. Hi, James. Hi, James. Of course, my favorite Spice Girl is Jerry. She was the ideas girl, and a lot of the spice flavor came from her, of course.
Cool. Richard, your turn. A little trivia about yourself.
This is a real Sophie's choice. How can I pick just one favorite Spice Girl?
No, not Spice Girl. How about a little trivia about yourself that people may not have known?
I can touch my nose with my tongue.
Isn't that a genetic thing? Like some people can't have the gene to do that. Anybody know? So
probably, yeah.
Yeah. Okay, cool.
I think maybe my tongue is detached somewhere where it's supposed to be attached. That's the problem. I can touch my chin too, but that's not really work appropriate.
Okay. My trivia is I actually am new to the crypto space. I have been actually in the game industry for 20 plus years, probably 25 plus years. And but I always have been passionate about crypto. I mine Bitcoin when it was still mineable with GPUs. I have an original wallet address, which I kind of need to probably sweep that at some point because that paper is getting pretty crusty. I think I'll need to figure out a way to get it into a proper hardware wallet now. But anyway, I always felt that crypto and gaming had an intersection. I just didn't realize how is now the in thing. Like metaverse and GameFi is all the rage discussing. But I can tell you right now, I've been thinking about it for years, and I'm glad it's finally coming. So if you want to talk about GameFi, metaverse, please drop me a line because I've been thinking about it for years, and I hope Chia will be a conduit for that as well. So anyway, with that, I want to thank you for everybody coming, and I want to thank the panelists for being here today. Just as a reminder, if you want any follow-up on any questions you have on Chialisp, please feel free to join our Keybase. Go to Chialisp channel and ask questions. We are here to help jumpstart the community, and we're glad you're participating in a hackathon or just trying to learn more about Chialisp. So with that, we are done for today, and our next Q&A session is going to be later today to cover a different time zone. So if you want to check out what that is, go to chialisp.com/training and see the next times. Okay, with that, thank you very much. Have a good day, guys.
Bye-bye, everyone.
Bye.